So we are going to talk about limits and continuity. You will find these topics in week 1. So you can go through box lectures and the theoretical concepts are discussed there. Okay. Besides these box lectures, I will suggest you to have a look on this first lecture video, that is Introduction, Limits and Continuity. And at the same time, you have to go through this one, indeterminate forms. So these two things are included in week 1. So before starting limits and continuity, what we have to do, that is, we need to know what is function. So you need to have this preconcept. There are several types of functions. It may be polynomial function, exponential function, logarithmic function, rational function. So all the types have been discussed in this lecture. Okay. So function, this is not included in our syllabus, but whenever we are trying to discuss limit and continuity, every time we are dealing with functions. So we will try to evaluate the limit of any function at any given point. We will try to check whether a function is continuous or not. So that's why everywhere we will see the applications of functions. So at first, we are starting from limits. Limit of a function. Let's say we have a function f of x. So we are discussing about single variable function y equals f of x, where x is the input and y is the output. Number of input is only 1. That's why based on this number of input, we can say that it is single variable function. Okay, that means how many inputs we have? We have total 1 input. So depending on this one, we can say it is single variable function. What is variable? All the letters from A to Z, let's say A, B, C, D, up to X, Y, Z, all these letters can be thought to be variable. You can think about X, Y, and Z for simplicity. Okay, we can take any value of X. X can be 0, X can be 1, X can be 2, it can be plus minus 2, like that. Similarly, we can take any value of Z, it may be 100, it is up to our choice. So since the values of X, Y, Z, A, B, C, all these things are changing, okay, that's why it is called variable. So the values are varying every time. So here we are trying to discuss limits of functions. Okay, so suppose we have a function, single variable function, and we want to evaluate the limit of that function when x approaches to a. So if we have a finite value finally, then we can say that limit of this function exists. Suppose we have the same mathematical notation, limit of f of x when x approaches to a. So this time we are getting, let's say, infinity. More specifically, we are getting plus infinity or minus infinity. If this is the case, then we can say that limit is not a finite value. So it is not bounded. Okay, it is unbounded, or we can say that it is undefined. So that's why what we can say, we can leave a comment that limit does not exist. So this session will be mainly problem solving session. We'll solve some problems and try to understand what limit is and how to deal with continuous functions. If we have this type of notation, limit of f of x when x approaches to a, if this gives us a finite value, let's say 1 minus 500, let's say we have 1.2, any decimal value, any large value, okay, all these are finite values. So it can be 2 by 3, so anything. So if the limit is finite, then we can say that limit of that function exists. But if we get plus infinity or minus infinity, that means limit is actually infinity. So that's why we can say that limit does not exist. Now we can take some examples. Suppose we have limit x approaches to 2, x squared plus 4. So we want to evaluate the functional value when x is approaching to 2. So we can understand that limit x approaches a, f of x. So this is going with the same notation, limit x tends to 2. We can say x approaches to a or x tends to a. So in the place of f of x, we have x squared plus 4, and the value of a is given as 2. So we know that f of x can also be thought as y, because y equals f of x. So if we take some values of x, we will get the values of y. So we are asked to find the value of y when x is 2. So we have x squared plus 4, that is f of x. So where we have x, we can plug 2. So that means 2 squared plus 4. So we are getting 4 plus 4, that is 8. So you have learned this tabular concept in your school or college level. So we are applying the same thing here. So when x is 2, the value of y is, or the value of f of x at x equals 2 is 8. So the same thing we are applying here. So we are trying to find the value of x squared plus 4 when x is approaching to 2. So we can plug 2 where we have x. So let me use another color so that you can easily understand. This is the place where we have to input, because x is the input variable. So other colors are same. So 2 squared plus 4, that means 4 plus 4, we have 8. So this is the limiting value of this function when x is approaching to 2. So we have found a finite value. That means limit of this function exists when x is approaching to 2. So we can say limit exists. Now let me break down the limiting notation. So we have limit of f of x when x is approaching to a. So this can be broken into two parts, left-sided limit and another one is right-sided limit. Any limit can be classified into two parts. We can say left-hand limit, this is the short form, right-hand limit. Or you can say this is the one-sided limit. This is another sided limit. This is also one-sided limit. If we are considering both left side and right side, then we can say we have both sided limit. So you have to cope up with these notations, these terms, so that you can easily understand all the concepts of limit. So you have noticed that I have used a negative sign and a positive sign. So these negative and positive signs are nothing but the directions. Okay, this is just saying us that we have to come from the positive side or from the negative side. This is the action of positive and negative that we have applied here in the superscript part. So this is just the direction, nothing else. So A plus is the same thing as A. A minus is the same thing as A. But whenever we have A plus, we will say that we are coming from the positive side to A. Whenever we have A minus, that means we are coming from the negative side towards A. So instead of A minus or A plus, we can use A at the end. So let me give you the geometrical notation. Suppose we are trying to evaluate the limiting value of any function. This green color curve is, let's say, f of x. So at any point in the number line, that is at x equals a, we are going to evaluate the limiting value. So say we have the limiting value here. This is the x length, this is y length. If we say limit x tends to a plus f of x, that means we are trying to find out the limiting value of f of x from a plus position. What is a minus? Let's say we have this notation for left-hand limit, limit of f of x when x is approaching to a minus. It means we are coming from the left side towards a. So a minus. This side is x greater than a, and this is the left side, which means x less than a. So also x greater than a means a plus, x less than a is denoting a minus. We have to evaluate both-sided limits, both left side, that is left-hand limit, and right-hand limit. Suppose we have any function, let's say f of x or any function g of x. It is sure that this is the plus infinity part, this is the minus infinity part, this is the plus infinity part, but this is the minus infinity part. We are checking the limiting value at any part, that is at x equals 2. So to evaluate the limiting value of f of x at x equals 2, we can break down the concept into two parts, left side limit and right side limit. That is the left hand limit and the right hand limit. So what is right hand limit? If we come from this part, this will be the right hand limit. That means we are approaching to x equals 2 from the right side. If we come from the left side, that is left hand limit. So we are coming from the left side towards x equals 2. Okay, so that's why, since we are coming from the right side, so it is 2 plus. So that's why this plus or the minus that we are applying here is just the direction. Our target is to find the limiting value of this function. So we can use left hand limit and right hand limit concept to evaluate this. So earlier we have mentioned that limit of any function, if it becomes finite value, then we can say that limit exists. Otherwise, limit does not exist. But now we are extending our idea that we are not confined into this concept only. We are now applying negative and positive directions. So this notation has been divided into two parts, that is left hand limit and right hand limit. So now we are going to discuss the definition of limit. So existence of limit of a function at a certain point. So we have f of x. We are trying to evaluate the limiting value when x is approaching to a. So limit will exist if left hand limit and right hand limit both are finite and both are same. So limit x tends to a minus f of x, limit x tends to a plus f of x if these two are finite. So why we are using this concept finite? Because already we learned that if the limiting value is finite value, then we can say that limit exists. So this limiting part has been divided into two parts. So this is a limit, this is another limit. So limit will exist if we have a finite value. So since we have a finite value, we can say that left hand limit exists. Since on the right side we have finite value, we can say that right hand limit also exists. But limit of the main function will exist only if left hand limit and right hand limit are same. You will understand if we take one example. So suppose we have a piecewise defined function. Piecewise defined function means suppose the domain is broken into several parts. Let's say we have x equals 1, we have x greater than 1, we have x less than 1. For x equals 1, we have suppose x squared. Okay. For x less than 1, we have x minus 1. And for x greater than 1, we have, let's say, 2x. So we can say that the function that we have f of x has three parts. So three pitches are here. First part, second part, and third part. That means the entire number line can be thought to be in this way. That is, this is x equals 1. This part is x greater than 1. And this part is x less than 1. For x equals 1, we have a function f of x equals x squared. You can see from here. For x greater than 1, we have a function 2x. For x less than 1, we have a function x negative 1. So you can see that we can understand by this way. This is f1, this is f2, let's say this is f3. So f of x has three parts: f1 function, f2 function, f3 function. But combinedly, we can say that this is a piecewise defined function. You will see this type of functions in this entire course. Okay, so that's why it's important to discuss with this type of problems. Up to now, we have understood that limit of any function will exist if it is a finite value. It is a real number or a finite value. Now we are extending our idea that limit of the same function will exist, but mathematically we are using a different definition. So what is the definition? Limit of this function will only exist if left hand limit and right hand limit are same. So what is left hand limit? Left hand limit is the same notation that we have written above, but here we have minus sign. What is right hand limit? Right hand limit is the same notation that we have written here, but with plus sign. This plus and minus are just the directions, nothing else. So if both left hand limit and right hand limit are same, then only we can say that limit of the main function exists. So we can see from here that we have a piecewise function. This will be the best example to understand what is the existence criteria of limit. So we have taken a function f of x. F of x has three parts. So some part is defined for x less than 1. Another part is defined for x greater than 1. And another one is for x equals 1. Let me write the question first. We want to evaluate limit of f of x when x is approaching to 1. This is our question. So we are fixing up our target. That is, we want to find the limiting value of this function when x is approaching to 1. So now let us have a look on f of x. So what is f of x? F of x has three parts: x minus 1, x squared, and 2x. X minus 1 is defined for x less than 1. X squared is defined for x equals 1. And 2x is defined for x greater than 1. Now we will try to evaluate the limit of this function. So first of all, we have to understand what is the meaning of x less than 1, x greater than 1, and x equals 1. So if we think about the number line, so that is the real number line or x-axis. So let's say this is x equals 1. So obviously it will be x equals 2, it will be x equals 3, it will be x equals 0, x equals -1, x equals -2. So what is our main point? We are trying to evaluate the limit when x is approaching to 1. So this is our main portion. Now the right side of 1 can be thought to be 1 plus. That means 1 plus something becomes 2. 1 plus something becomes 3. So that's why we are denoting a notation that is the right side is 1 plus. Or we can think about another way. We are coming from the right side towards 1. Similarly, the left side of 1 can be thought to be 1 minus position, or we can say we are coming from the left side towards 1, because we want to evaluate the limit at x tends to 1. So that is our target. Now 1 plus is mathematically known as x greater than 1. 1 minus is known as x less than 1. And x equals 1, you already understood that this is x equals 1, same thing. So we have to understand which part is the rightward part, which part is the leftward part, and which part is the equal one. So we have already figured out that the right portion can be worked as the right hand limit, the left portion can be applied in left hand limit, and x equals 1 will denote this function. So since we have x less than 1, let's say this is the leftward function. We have x greater than 1. This will be the rightward function. I am writing r, that is the short form of rightward function. X equals 1. Let's say this is the equal part. Okay. Now we know that we have to evaluate the limit of this main function f of x when x is approaching to 1. Now let us break down this concept. So it can be broken into two parts. Limit x tends to 1 minus f of x. Another one is limit x tends to 1 plus f of x. So now we have to understand what is the meaning of 1 minus and what is the meaning of 1 plus. So actually this minus and plus are the directions. This will be just applied to get the right function so that we can input the right function here. That is our main target, because f of x has several parts. So which function can be plugged here? Which function can be plugged here? That is the main question. So we are now denoting this one as left hand limit and this one as right hand limit. So we have to find both left-hand limit and right-hand limit. Now, let me write the same thing again. Limit x tends to 1 minus. So 1 minus, that means leftward function. So already I have mentioned that LER. So which one is the leftward function? Obviously x minus 1, right? So we can input this one here. Let us find the right-hand limit. X tends to 1 plus. So which function, which f of x can be plugged here? We have to understand. Since we have 1 plus, this plus will guide us that out of these three functions, which one we have to take. So you can understand that I have mentioned here R. So R means rightward function. So the function 2x can be written here. Now, what we can do, you can easily understand that this minus and plus are nothing but the directions. So we can easily drop this minus and plus sign. So actually we have limit x tends to 1 and the same function x minus 1. See, I have now dropped this minus sign. I have not written minus here. So this is the case what we have to do while evaluating the left-hand limit and right-hand limit. So right-hand limit x tends to 1. Now you can see that I have not written plus here. So the action for plus and minus are already done. This plus and minus has just guided us to evaluate or understand which function can be plugged here in these positions. So we have understood that leftward function will be this one, rightward function will be this one. So now let us input 1 where we have x. So x minus 1, that means 1 minus 1, that is 0. So what is the value of left-hand limit? Left-hand limit becomes 0. Since 0 is a finite value, so we can say that left-hand limit exists since it is a finite value. Now let us have a look on the right-hand limit. Limit x tends to 1, 2x. Where we have x, we can plug 1. So 2 times 1, that is 2. So right-hand limit becomes 2. Right-hand limit is also a finite value. So right-hand limit also exists. But combinedly, we have to think about the main limit from where we have this left-hand limit and right-hand limit. So we need to remember this main limit. Don't forget this one. So left-hand limit is finite. That means left-hand limit exists. Okay. Right-hand limit is also finite. We can see right-hand limit is 2. Okay. So this one exists. This one also exists. But the main limit will only exist if and only if this left-hand limit and right-hand limit are equal. So we can see that left-hand limit is 0 and right-hand limit is 2. So we can say that left-hand limit not equals right-hand limit. So we can leave a comment, that is limit x tends to 1 of the main function. That means the problem that is given earlier. So this one, where f of x is these 3 parts. So this main limit does not exist. So I hope you have understood somehow the concept of limit. So the short summary is, if left-hand limit and right-hand limit are same, at first those two have to be finite. So if left-hand limit and right-hand limit are same, we can say that limit exists. So let us have a look on another example. So suppose we have a function f of x equals sine x squared Suppose we have x, and let's say we have x cubed -1. So this time we have again, suppose this is x less than 0, this part is x greater than 0. Suppose we have a single function, f of x equals sine x. So you can understand that this sine x has the domain as the real numbers. That means x can be anything. X can be 0, x can be 30 degree, 45 degree, it can be 1000, it can be minus 5000, anything. So we can plug any value here. That means if we think about the real number line, we can take any larger value, we can take any smaller value, we can take any value a. So if we think about, we have x equals a. The question is, how does this f of x has 3 parts? So to answer this one, I would like to take this example. We have f of x equals sine x. So we can input anything. That means the same function is defined for all x belongs to R. Or we can extend our idea, that is the same function is defined for x equals 0, x greater than 0, x less than 0. That means anything we can input. We can think about another value, x equals 1, x greater than 1, x less than 1. If this a is 1, we can also think about, let's say a is 2. That means x less than 2, x equals to x greater than 2. That means now we can say that the single function can also be thought as piecewise defined function. Let's say we have sine x, we have again sine x, we have again sine x. So this is for x less than 0. It may be x equals 0, it may be x greater than 0. So have a look again. We are taking x less than 0. That means the left side is covered. Okay. Similarly, we are taking x equals 0. This portion is covered. X greater than 0. This portion is covered. That means we are having the total real number line R. So we can say that the single function can be thought as piecewise defined function. So any function can have several pieces. Okay, so that's why we can think about piecewise functions. So the question is, we have to evaluate the limit. So let me write here, evaluate limit of f of x. Remember that f of x has 3 parts, so we have to think about the whole concept. So remember, f of x is defined for x less than 0, another one is for x greater than 0, and the last one is for x equals 0. So we have to evaluate this limit when x is approaching to 0. The same question can be written in alternative way, that is, check whether limit x tends to 0, f of x exists or not. So actually I have written 2 questions, but the process of answering is same. So let us write the main part, that is limit x tends to 0, f of x. So we want to evaluate this one. So it can be easily done if we have a single function, let's say x squared. So then what we can do, limit x tends to 0. So on right side, limit x tends to 0. So actually 0 is squared, that is 0. So that can be easily found. But since f of x has 3 parts, so that's why we must have to go with the concept of left hand limit and right hand limit. So let us find left hand limit and right hand limit. So in left hand limit, we will write the same thing here, f of x, x tends to 0. On right hand limit, limit f of x, x tends to 0. But since we are going to find left hand limit and right hand limit, so why not we use minus for left hand limit and plus for right hand limit. Now we want to understand which function will be plugged here, which function will be plugged in this position. So that is a big question. So we need to find leftward function, we need to find rightward function. So leftward means, always remember, less than or minus. Rightward means greater than or plus. So we have three functions. We can see sine x squared, x, and x cubed -1. So which function will be leftward? We can see x less than 0 is given. So the corresponding function sine x squared will be the leftward function. X greater than 0 is given here. So this function will be the rightward function. Since x equals 0 is given, so we can think about the last one is the equal part. That is, it is coming from the equal function. So although this e part is not applying here, but we need to understand this concept also if we move to the concept continuity. But for this problem, we don't need this e part. We just need L and R. So we have figured out which function is L and which function is R. So that is the main condition at first we have to check or find out. So limit x tends to 0 minus. So which function will be plugged here? Sine x squared, x, or x cubed -1? Obviously,
Sine x squared.
Sine x squared.
Sine x squared.
Yeah. So sine x squared. Now let us evaluate this one. Okay. One thing I need to again mention that since we have figured out that sine x squared will be plugged here, so no need to write this minus sign again. Okay. This is just for the directions. So now we can input the value of x where we have x. So this is the position where we have to input x. So now sine 0 squared. You know that sine 0 squared is sine 0. Sine 0 value will be 0. So that is
0.
The left hand limit. Yeah. So we have found the left hand limit. It is a finite value. Since it is finite, it is required to find also the left hand limit. Sorry, right hand limit. But if anyhow we find infinity in left side limit, so there is no need to find right hand limit. We can easily say that this one doesn't exist. Okay, so since left hand limit is finite, it is 0. So let's check the right hand limit also. So limit x tends to 0 plus. So 0 plus or r or rightward function is just x. So that's the reason why I have written L and R at first. Okay, whenever you will find some problems, at first I will request you please mention these things with pencils. Okay, otherwise you will have a problem to figure out the main functions, leftward function, rightward function. So now let us find this one. So we have to plug the limiting value. So x tends to 0. Where we have x, let's input 0. So right hand limit is now 0. That is also finite. So now we can say that left hand limit exists, right hand limit exists because both these are finite. So what is the main limit? This is also the same. Since left hand limit and right hand limit are same, so let us write a comment since left hand limit and right hand limit are same, so limit of the main function f of x when x is approaching to 0 exists. So what is the value of this limit? It will be same as the left hand limit and right hand limit. So this is 0. So this is how we can evaluate limit. Suppose we have a function f of x equals e power x. Okay, so we are trying to evaluate, let's say, limit x tends to 1 of f of x. So what will be the limiting value of this function? Or the question may be, check whether limit exists or not. So this time we have taken a single function, f of x. So our main part is this one. So limit f of x, x tends to 1. Since this is a single function, we can go directly, but I am going with the same technique that we have learned earlier. So we know that this main limit can be divided into 2 parts. So let me write down here. Let's say this is method 1. So limit of f of x when x is approaching to 1. So it can be divided into 2 parts. Limit of f of x when x is approaching to 1 minus, this is minus sign, 1 minus f of x. And similarly, we will have right hand limit, limit of f of x when x is approaching to 1 plus. We need to now find which function is leftward, which function is rightward. So we have a single function, f of x equals e of x only. So since it is a single function, it is defined in the real number line. So that's why we can also think about as a piecewise function. We can take 2 functions, 3 pitches, or we can take 4 functions, whatever we want. Okay, so let's say we have e power x, e power x, e power x. This is for x less than 1. This is for x greater than 1. This is for x equals 1. All the way we have the same function. So for x less than 1 or 1 minus, we have same e power x. For x greater than 1, we have same e power x. So limit x tends to 1, we can drop this minus sign now. Limit x tends to 1, we can drop this plus sign now. Now we can input the limiting value, e power 1, e power 1. So what is the value? E. So since left hand limit is e, right hand limit is also e. E is an irrational number. It is also a real number. So this is a finite value. So limit exists. So the main limit will be also e. So since for both cases we have applied the same function, so this is a waste of time. We don't need these 2 concepts. Okay, we can actually find the one part only. So let's say we are going with another method, method 2. So we are trying to evaluate limit of f of x when x is approaching to 1. Since we have a single function only, so it will be just here e power x. Now we can input limit e power 1, where we have x, we are plugging 1, so it is just e. So we are getting the main answer. So e is finite. That means we have discussed two definitions. At first, we have discussed this one. If any limit is finite value, then limit exists. And we have also discussed another definition. If we have some piecewise function, then we can use this concept. We will break down the main limit into left-hand limit and right-hand limit, that is on both sided limits. We have to find left-hand limit and right-hand limit. If these two limits are same, then we can say this limit will be the same one. So we have actually two methods. If we have a single function, then go with the first method. If we have several piecewise defined functions, so you can go with left-hand limit and right-hand limit concept. So now, since we have learned limit, now we are ready to learn continuity. So what is the definition of continuity? The continuity of any function f of x, y equals f of x. So the continuity of any function y equals f of x at x equals a is defined as follows. If limit exists and it is same as the functional value at a. So the continuity of any function f of x at x equals a is defined as this way. Limit must have to be exist, and this should be equal to the functional value f of a. What is the meaning of functional value? Suppose we have f of x equals x plus 1. Now we want to input 1. So where we have x, we are plugging 1. So 1 plus 1, that means 2. This is the functional value, f of a. So let's say we are plugging 0, where we have x, 0, plus 1. So we have 1. So this is the functional value. So that means I'm talking about f of a. So f of a should be same as this one. What does it mean? Limit exists. It means left-hand limit and right-hand limit should be same. The meaning of this sentence, these two words, means left-hand limit and right-hand limit must have to be same. That means for all the problems what we have done, we have to do the same thing for continuity also. So at first we have to check the left-hand limit and right-hand limit. If left-hand limit and right-hand limit are same, we can say that limit exists. If these two conditions are same, then we have to look on the last condition. What is the functional value at a? If the functional value is also same, we can say the function is continuous at x equals a. So we want to check the continuity. So check the continuity of, let's say we have a function f of x equals cosine of x e power x and x plus 1. So the first one is, let's say, defined for x less than 0. It is for x greater than 0. And this one is for x equal to 0. We have to check the continuity of this function at x equals 0. For continuity, you must know that we have to check the existing criteria of limit. So in this portion, we don't have any limiting concept, but in the definition of continuity, we have the limiting concept. So that's why this time we have to construct the limit. For the previous problems, the main notation were given, but for this problem, we have to write down this one. We are trying to check the continuity of this main function f of x when x is approaching to 0. So for checking continuity, we have total 3 conditions. Left hand limit should be equal to the right hand limit, and it should be same as f of a. What is the value of a? If we compare with x equals a with x equals 0, then value of a is 0. So these are the conditions that we have to fulfill. Left hand limit equals right hand limit equals functional value. So now let us break down this one. So left hand limit, right hand limit, limit x tends to 0, f of x, limit x tends to 0, f of x. So 0 minus 0 plus. Now we have to find out which one is leftward function, which one is rightward function. So leftward means less than. Let us figure out which one is leftward, which one is rightward. So x less than 0, that means this function cos x will be leftward. X greater than 0, that means this function will be rightward. Okay, these two information are enough. This is the leftward and this is the rightward. Okay, so limit x tends to 0 minus, no need to write minus now because we have figured out which function should be placed here. Left cosine x. Right hand limit x tends to 0 plus, we are dropping plus sign now. So f of x should be e power x. This is very crucial part. You have to be very careful here. You have to be sincere while choosing the functions. Otherwise, you will go to the wrong direction. So now let us look at where we need to input the value of x. In this portion, we have to input 0. So cos 0, the value is 1. Left hand limit is 1. E power 0. E power 0 is also 1. That is right hand limit is also 1. So now we can say that since left hand limit equals right hand limit, therefore limit of the main function exists. So for continuity, at first we have to check whether limit exists or not. Yeah, left hand limit and right hand limit are same. So these two conditions are okay. Now we have to find out what is f of a. That means a means 0. So a equals 0. Now the equal part will come. We have x less than part, we have x greater than part, and we have also x equals part. So this is the leftward function, this is the rightward function. Besides this, we should mention equal function. So this function should be chosen while evaluating f of 0. So f of x equals only x plus 1. Let's try to understand why we have chosen x plus 1, because now we are trying to evaluate the functional value of f of x only at x equals 0. That's why f of 0 is written. That's why f of 0 is written here. So just like leftward and rightward functions, we have to also choose which function is the equal function. So we have already understood that in this function, we have to input 0. So 0 plus 1. Now f of 0 is also 1. So that means all the three conditions are satisfied. Left-hand limit and right-hand limit and functional value at 0 are same. So we can say that since left-hand limit equals right-hand limit equals functional value at 0, all these are same. So the main function, the given function f of x is continuous at x equals 0. That means I am repeating the same sentence that is written here. Check the continuity of this function at x equals 0. This piecewise function is continuous at x equals 0 because left-hand limit, right-hand limit, and functional value, all these are same. So I hope you have understood up to this part. So that's all for today. We will meet again. Thank you.